Good day everyone, my name is Hil Villarmosa and I'm going to discuss to you the Module 9, which is the Personal Protective Equipment. This is the last module in Unit 2 and it is very important one. Although we've been mentioning personal protective equipment right from the start of this course, we still feel that we have to devote a full module to it. We must review the PPE we have already mentioned and see if there are others that you need to acquainted with. Remember that PPE can save your life or that of your coworker. The PPE must be considered only after engineering and administrative controls have been found ineffective, not feasible or insufficient. It must be used only as a last resort. The selection of PPE must comply with the existing OSH standards, and using these in the workplace must be combined with training and orientation on their proper use, limitations, and advantages. You must monitor proper usage and maintenance of PPE in order to attain satisfactory performance and properly administer the PPE program in your area of responsibility. This module thus aims to impart the proper usage of PPE to the learner in order to prevent accidents at work. Objectives. Working on this module should help you to know the classifications of hazards, distinguish the appropriate type of PPE you need in your workplace, know the limitation of PPE, develop programs to introduce PPE for your company. But first, let us define what is hazard, because PPEs won't exist if there are no hazards around us. Defining hazards. What is hazard? A hazard is anything that produces adverse effects on anyone. Examples of hazards are slippery floors, falling objects, chemicals, and many more. What do you think make these occurrences hazardous? As discussed in Unit 1, Module 3, unsafe or unhealthy acts bring about unsafety or unhealthy conditions, causing hazards in the workplace. Although some hazards are intrinsic in nature, a human hand is still behind most of the hazards we now encounter. Classification of hazards. Hazards may be classified into direct, physical, chemical, biological, and ergonomic. Let us discuss each of these. Direct hazards. These are very common in companies that utilize oil, water, or any liquid in the production process and in the construction industry where there are a lot of falling debris like small pieces of wood, nails, and tools. Examples of direct hazards are unguarded moving parts of machines, falling or flying particles, and slippery floors. Physical hazards. Physical hazards is an agent, factor, or circumstance that can cause harm with contact. They can be classified as type of occupational hazard or environmental hazard. Physical hazards include noise, extreme temperatures, radiation, extreme pressure, and vibration hazards. Noise. The following table is the allowable time a worker can stay in a work without a hearing protection. For an 8-hour exposure, the allowable noise level is 90 decibel. For an 4-hour exposure, the allowable noise is 95 decibel. For an 2-hour exposure, the allowable noise level is 100 decibel. And lastly, for an hour exposure, The allowable noise level is 105 decibel. Extreme temperatures. There are two types of extreme temperatures. These are extreme heat and extreme cold. Extreme heat can cause heat stroke, and extreme cold can cause hypothermia. Radiation. Radiation also has two types, the ionizing radiation and non-ionizing type. Ionizing radiation. Ultraviolet light or alpha particle. It is from the sun and can be shielded by paper. Beta particle. It can penetrate paper but not concrete. Gamma ray can penetrate concrete, and this can be shielded by using lead like in the X-ray room, which is made up of sheeted lead in between concrete to prevent outside exposure. Next is the non-ionizing radiation. Radio waves, electric waves, and infrared rays is an example. An example is the welding process, which produces infrared rays that can damage the skin. Radiation is dangerous because it cannot be detected by the five senses, but it destroys the cells and tissues of living organisms and has long-term effects. Examples of radiation: ionizing radiation, ultraviolet rays from the sun, and gamma rays. While non-ionizing radiation, example of it is a welding process and it can damage the skin. Next. 3 safety practices for controlling body exposure to radiation. Time. The shorter the time, the lower the exposure received. Distance. The greater the distance, the lower the exposure received. Shielding. It may be lead, steel, iron, or concrete. Extreme pressure. These are pressures beyond the allowable levels needed by the human body. Normal atmospheric pressure is 14.7 psi, and even a small change in the atmospheric pressure has a corresponding effect to humans. Examples of workers exposed to extreme pressure are those involved in excavation work, scuba diving, and piloting airplanes. Vibration. Exposure to vibration could have a negative effect of the employees. It could damage joints, muscles, circulation, and sensory nerves. This could lead to considerable pain, time off, or even disability. Chemical hazards. These are substances in solid, liquid, or gaseous forms known to cause poison, fire, explosion, or ill effects to health. Examples include gases, fumes, vapor, mist, and dust. These are airborne particles or airborne toxic elements that evaporate in the air and can cause irritation, discomfort, and even death. Chemical routes of entry to the body are by inhalation, ingestion, and skin absorption. Biological hazards. These are hazards caused by viruses, fungi, and bacteria. And lastly, the ergonomic hazards. These are caused by improper posture or postural stress. Hazard control measures. There are three methods in controlling hazards: engineering, administrative, and personal protective equipment. Engineering method. This is the application of engineering technology to control hazards. An example is machine guarding, which prevent anyone from coming in contact with moving parts of a machine during the operation. Other examples are installation of safety devices like emergency stop, limit, grab wire, and photoelectric switches. These prevent accidents in case of improper work practices. Other forms of engineering method involve substituting hazardous substances with less hazardous ones and isolating hazardous process. Administrative method. This aims to minimize the exposure of humans to workplace hazards and employs administrative approaches such as rotation and shifting. And PPE. These are considered as the last line of defense. These devices provide limit protection to the ones using them. Introducing the PPE. Once it is decided that personal protective equipment is going to be used, then the following steps need to be undertaken. Policy. Write a policy on the usage of PP and communicate it to the employees and visitors as needed. The policy should state the need for the use of PPE. It may also contain exceptions or limitations of the use of PPE. Select the proper type of equipment. In selecting the proper equipment, after the need for personal protective equipment has been established, the next step is to select the proper type. In selecting the proper protector, consideration should be given to the kind and degree of hazard, where a choice of protectors is given and the degree of protection required is not an important issue. Workers' comfort may be a deciding factor. The first step in selecting PPE for respiratory protection is to contact a supplier. Manufacturers and distributors do not just help in the selection of the most useful equipment, but can give valuable aid in fit sizing, cleaning, care, and storage. Implement a thorough training program. Proper training. The next step is to obtain the workers' complete compliance with requirements to wear the PP. Several factors influence compliance. Among them are the extent to which the personnel who must wear the equipment understand its necessity, the ease and comfort which it can be used, or work with a minimum of interference with normal work procedures. A training program outline may include describing hazards and or conditions in the workplace, telling what can and cannot be done about them, explaining why certain types of PPE have been selected, discussing the capabilities or limitation of the PPE, demonstrating how to use, adjust, or fit a PPE, practicing using PPE, and explaining to workers how to deal with emergencies. And next is the ensure that employees know the correct use and maintenance of the equipment. All equipment must be inspected periodically before and after use. A record of all inspections with the date, tabulated results, the recommendation of the manufacturer for the maintenance of the device, and the repair and replacement of parts supplied by the manufacturer of the product should be kept. And lastly, the enforcement. Enforce proper use and maintenance of the PPE. Employees need to know how the use of PPE will be enforced. Many companies have some kind of disciplinary actions such as unpaid time off and finally termination. The enforcement of the use of PPE is critical to a successful program. Uses of uses of PPE are the following: head protection, eye protection, face shields, ear protection, respiratory protection, hand and arm protection, foot and leg protection, fall protection, torso or full body protection. Head protection. A safety hat is a device that provides head protection against impact from falling objects and protection against electrocution. Safety hats should be inspected prior to each use. Next is the eye protection. It is a protective gear for the eyes and sometimes designed to reduce the risk of injury from hazards caused by flying particles, sparks, light radiation, splashes, and gases. Eye protectors must meet the following minimum requirements: provide adequate protection against a particular hazards for which they are designed, be responsibly comfortable when worn under the designated conditions, fit snugly without interfering with the movements or vision of the wearer, be durable, be capable of being disinfected, be easily cleaned, be kept clean and in good condition. Face shields. Face shields should only be used as eye and face protection in areas where splashing or dust rather than impact resistance is the problem. In the case of grinding operations, a face shield is the only secondary protection to other protective devices such as safety goggles. Ear protection. It refers to a device used to protect the ear, either externally from elements such as cold, intrusion by water, and other environmental conditions, debris, or specifically from noise. Examples of ear protection are earplug, the orange one, and earmuffs, the one in the middle, and canal caps, the one in the third. The prevention of excessive noise exposure is the only way to avoid hearing damage. Engineering and administrative controls must be used if acceptable sound levels are exceeded. If such controls fail to reduce the sound levels to acceptable limits, personal hearing protection must be used. Earmuffs must make a perfect seal around the ear to be effective. Respiratory protection. It is a respirator. Respirator is a device designed to protect the wearer from inhaling hazardous atmospheres, including fumes, vapors, gases, and particulate matter such as dust and airborne. Respiratory protection is required when engineering improvements and administrative controls can eliminate risks. risks. Engineering controls include isolation of the source of contaminants, design process or procedural changes, and etc. Administrative controls, on the other hand, include monitoring, limiting worker exposure, training, and education. Hand and arm protection. Hand and arm protection is required when workers' hands are exposed to hazards such as harmful substances that can be absorbed by the skin, severe cuts or lacerations, severe abrasions, chemical burns, thermal burns, and temperature extremes. Example of hand protection is appropriate gloves, barrier cream, the one in the middle, and sleeves for arm protection. Selection of hand PPE shall be based on an evaluation of the performance characteristics of the hand protection relative to the task to be performed, conditions present, duration of use, and hazards identified. Gloves are often relied upon to prevent cuts, abrasions, burns, and skin contact with chemicals that are capable of causing local or systematic effects following dermal exposure. There is no one type of gloves that provides protection against all potential hand hazards, and commonly available glove materials provide limited protection against many chemicals. Therefore, it is important to select the most appropriate glove for a particular application and to determine how long it can be worn and whether it can be reused. It is also important to know the performance characteristics of gloves relative to the specific hazard anticipated. Example given is a chemical hazard, cut hazard, flame hazards, and etc. Before purchasing gloves, request documentation from the manufacturer that the gloves meet the appropriate test standards for hazards anticipated. Next, foot and leg protection. It is required when working in places where there is a danger of foot injuries due to falling or rolling objects, or objects that may pierce the sole of the shoe, or when an employee's feet are exposed to electrical hazards. The one in the left is a called conductive shoes. It is used to protect against the buildup of static electricity or equalize the electrical potential between personnel and the ground. These shoes should be worn only for the specific task for which they are designed, and should be removed at a task completion and not used as a general purpose footwear. This type of shoes must not be used by personnel working near exposed energized electrical circuits. Personnel must avoid wearing 100% silk, wool, or nylon hose of socks with conductive hose because these materials are static producers. Likewise, foot powders must be avoided because they are insulators and interfere with electrical conductivity. And the one in the left side is the electrical hazard safety shoes. These are non-conductive and protect against open circuits of 600 volts or less under dry conditions. The insulating qualities may be compromised if the shoes are wet. The rubber sole is worn out, or metal particles are embedded in the sole or heel. Electrical hazards shoes are not intended for use in explosive or hazardous locations where conductive footwear is required. This footwear should be used in conjunction with insulated surfaces. Fall protection. It is the use of controls designed to protect personnel from falling, or in the event if they do fall, to stop them without causing severe injury. These are the three fall protection system: trouble restraint system, fall arrest system, and lifelines. Trouble restraint system is an assembly composed of body belt and proper accessories that prevent a worker in a high elevation working area from traveling to an edge where the occurrence or fall may happen. Fall arrest system is an assembly composed of full body harness, safety lanyard and proper accessories, or a safety net which protect a worker after a fall by stopping the fall before hitting the surface below. Lifelines shall be secured above the point of operation to an anchorage or other structural member. Next is the torso or full body protection. It must be provided for employees if they are threatened with bodily injury of one kind or another while performing their jobs, and if engineering, workplaces, and administrative controls have failed to eliminate these hazards. These protective clothing come in a variety of materials, each suited to particular hazards. These materials include the following: paper like fiber, treated wool and cotton, duck, and leather. Paper like fiber is a disposable suits made of this material provide protection against dust and splashes. Treated wool and cotton adapts well to changing workplace temperatures and is comfortable as well as fire resistant, while duck, this closely woven fabric fabric protects employees against cuts and bruises, while they handle heavy, sharp, or rough materials. And lastly is the leather. Leather protective clothing is often used against dry, heat, and flame. Be aware that different materials will protect against different and physical hazards. When chemical or physical hazards are present, check with the clothing manufacturer to make sure that the material selected will provide protection from the specific chemical of physical hazard in the workplace. So we are done discussing about PPE. So now let us discuss what is Rule 1080. Rule 1080 of the Occupational Safety and Health Standards requires employers to provide appropriate personal protective equipment to workers. Employers can be held liable if they fail to furnish their workers with the necessary PPE. These are the general provisions of the Rule 1080. 1081.01. Every employer shall, at his or her own expense, furnish his or her workers with protective equipment for the eyes, face, hands, and feet, protective shields and barriers whenever necessary by reason of the hazardous nature of the process of environment, chemical or radiological or other chemical, mechanical irritants or hazards capable of causing injury or impairment in the function of any part of the body through absorption, inhalation, or physical contact. Next is the 1081.02. All protective equipment shall be of approved design and construction appropriate for the exposure and the work to be performed. Next is the 1081.03. The employer shall be responsible for the adequacy and proper maintenance of personal protective equipment used in his workplace. And lastly, 1081.04. No person shall be subjected or exposed to hazardous environmental condition without protection. So to sum it up, you must consider many factors when selecting PPE to protect yourself, your colleagues, or your workers from workplace hazards. With all of the types of operation that can present hazards and all of the types of PPE available to protect the different parts of a worker, body from specific types of hazards. This selection process can be confusing and at times overwhelming. Because of this, it is highly recommended that you implement a PPE program to help you systematically assess the hazards in the workplace and select the appropriate PPE that will protect your workers from those hazards. The basic information presented here attempts to establish and illustrate a logical, structured approach to hazards assessment and PPE selection and application for you to use as a starting point for your PPE program. I think we are already done, so these are the references. I'm sorry about that. These are the references. Yeah. Thank you all for listening. Stay safe and God bless.